Welcome everyone. We'll give people a couple minutes here to log in and we will get started shortly. Thank you. All right, go ahead, Katie.
All right, thanks everyone for joining, and we'll get started. So some quick housekeeping. This webinar is recorded and we'll make the PDF as well as the recording available to everyone after the webinar. Everyone's muted and you're not on video. So if you have any questions or comments, please enter them into the chat or the Q&A and we'll address those at the end of the webinar. So first we'll go over some introductions and then an overview of the Atlas, and then we'll go over some discussion prompts because we want to have a nice full discussion towards the end of the webinar. Heike will go over some backend architecture for the Atlas. I'll talk about some of the data on the Atlas, and then Aidan will talk about the capacity factor tool, and Paul will lead us in a live demo of the features, and then we'll discuss some of the Atlas and what you all would like to see added to it. So some introductions. I'm the new project lead on the Atlas, and I'm relatively new to NREL, started in April, and really excited to be part of this project. Haiku, if you'd like to introduce yourself.
Yeah, absolutely. Hello, everyone. My name is Haiku Sky. I'm a product and project manager at NREL, and yeah, part of what I do is oversee the developments, or is the product design and developments of various web applications, including the Marine Energy Atlas. So excited to be here today and to be a part of this group showcasing the latest work.
And yeah, hi, my name is Aidan. I'm been at NREL for quite a while now, and I'm pretty heavily involved in the resource assessment work that we do here. In combination with the Atlas, I do a lot of the development of the analysis tools, building some of the algorithms, and working pretty closely with our cloud team to bring it all to you.
Hi, my name is Paul. I work at NREL as the technical lead and software architect for the geospatial data science team. My role on the Marine Energy Atlas was as the primary software developer in charge of the web application specifically and the services that support the web app.
So the Marine Energy Atlas is a knowledge hub on Primer, the portal and repository for information on marine renewable energy. The Atlas is an interactive web app that allows users to visualize, analyze, and download marine renewable energy data. The overarching goal of the app is to make it easy for different stakeholders to access data that can help them plan for marine renewable energy projects. The data can be visualized in the app to quickly get information or downloaded for detailed analyses. And we have some in-app processing and analytical tools that we'll talk about today. The Atlas is set up in a way so that our team can add layers and tools that are useful for different stakeholders, which is why we'd like to hear from you on what you want to see in the Atlas. So as I mentioned earlier, at the end of the webinar, we're going to have a Q&A and discussion, and we'd love to hear your thoughts on what to add to the Atlas or how to improve it. What sort of information, data, and tools would be helpful for you? So keep those in mind and let us know. So Heike will talk about Vader.
Yeah, thanks, Katie. So a couple slides back when Katie mentioned or showcased the bullet list, the last bullet there said future proofing. And so one of the reasons we wanted to showcase the backend architecture is just to mention that it's really a modern and highly robust platform that doesn't just create an application that is performant and useful for now, but is really accommodating and capable of any improvements, whether that's in terms of new data or completely new features in the application. So that's what I'm going to focus on in this slide and the next, just very briefly. So the backend architecture is something that we call VADR, and this stands for the Visualization, Analysis, Research, and Design. Obviously, no affinity to Star Wars. This essentially is a framework that combines web applications, web services. It also integrates continuous integration, continuous deployment infrastructure, so CI/CD, and it's all built within a monorepo for the code base. Additionally, it uses a whole suite of Amazon Web Services, AWS cloud resources, which I'll talk about in the next slide. So what this, oh, perfect, thanks, Katie. And so what this all means is that, again, it's a really modern set of web data libraries, web libraries, modern architectural components to just make for a really good, as good of a user experience as possible. Okay, to go a little deeper, just in case anyone's interested in what the backend architecture is for at least in relation to the AWS services. So in terms of our products that we offer within VADR and obviously within the Marine Energy Atlas, we have analysis of web mapping applications, dynamic analysis tools, big data download services, map tile, as well as data services, and user authentication services. And I won't go into any detail of the 5 subsequent boxes below the VADR products, but essentially this just gives an overview of that. This platform's architected to be highly robust. It handles a lot, and it will allow for the Marine Energy Atlas to continue to grow, and in the meantime be hopefully the best it can be for all users of the application. And just before I pass on the mic, I do want to say that one of the best ways we can improve the application is through user feedback. So if there's anything you really like, anything you don't like, anything that you think could be improved to make things more efficient, please reach out. It really helps us outline where the application would be improved, where we can even improve backend architecture. So on that note, I'll go ahead and pass on the mic. Keep moving forward. Thank you.
Okay, so one of the main data sets on the Atlas is the WPTO Wave Hindcast Dataset. And it's a multi-lab collaboration between the Pacific Northwest National Laboratory, Sandia National Laboratory, and NREL. It contains the highest resolution time series data of wave attributes in US waters. The data currently available on the Atlas are coastal waters within the US exclusive economic zones for Alaska, Hawaii, the West Coast, and the East Coast. For details on the WPTO Wave Hindcast dataset, be sure to attend the webinar hosted by PNNL on September 27th. Other data on the Atlas includes the ocean current data shown here, locations of wave buoys from the Coastal Data Information Program and National Data Buoy Center, and ocean thermal data. So we're expanding the data sets available on the Atlas. The Wave Hindcast dataset has been extended from 32 years to 42 years. And new WPTO datasets that will be on the Atlas soon include the Gulf of Mexico, Pacific Islands, and the Gulf Stream. Upcoming tidal data sets will have similar accessibility and visualizations as the wave data sets, and those will be a little bit closer and next to within tidal inlets in various locations. And then by the end of this year, we'll be ingesting the OES data sets, and those will be available next spring. And these data sets include information on marine energy facilities and projects that are ongoing, as well as geopolitical data and environmental data like marine protected areas. So I'll pass this off to Aidan to talk about the capacity factor tool, which is a really interesting and exciting in-app processing tool in the Atlas.
Yeah, thanks, Katie. Yeah, diving into one of our new major feature upgrades for this year is our capacity factor tool. Which represents a sort of the start of our distinction of the Marine Energy Atlas to be a tool that we can actively use to analyze data as opposed to just being a repository to get the data. So with this, we're definitely pretty excited for it. With the capacity factor itself, effectively can give you, based on any sort of wave energy converter, the ratio of the time average power output that it can do in a certain location versus what it's capable of doing. So it's maximum power output. So through this, you get a nice percentage value, which is applied across the entire data set. So millions of spatial points to give you those types of values, which you can go on to further download and use to get real power values or do any type of analysis. But really, this does represent a major push forward in how we're behind the scenes pre-processing a lot of the data and using a lot of this data to make these calculations, which can require a significant amount of computing power, make those really accessible to end users. Next slide, Katie. And building on this feature, we're really trying to provide a lot of accessibility tools, which, after this slide, we're going to take you through a demo of, so I won't spend too much time. But yeah, this is something that's definitely expanding. And on the back end, using a lot of probability distributions that are driving a lot of these calculations, there's a lot of potential for new tools to be added into this. So I'm very excited to hear what would be useful and what we can do next year to improve this. But yeah, instead of me just rambling on about this, I will pass it over to Paul so he can actually show you. No
Thanks,
problem.
Aidan.
You're welcome.
I think, let me gain control so that I can share. Thanks, Katie. Okay. All right. So yeah, I'd like to take you through a sort of quick and high-level demonstration of the Marine Energy Atlas itself. There's a lot of features packed into the application, and it's impossible to talk about all of them in a short period of time. And so on that note, I'd like to point out there is a feature here in the left called Take a Tour. And so I'm not going to walk you through the tours today. The tours would be more useful for self-discovery. I'm going to be giving you a personal guided tour in a minute, but I just wanted to make note that this is here. So in the future, if you're using the Marine Energy Atlas, there are tour topics for each and every section of the Atlas. I'd like to discuss the Marine Energy Atlas. So this is, as Katie mentioned, we're providing users with a web portal for visualizing, analyzing, and downloading spatial data sets that are relevant to marine renewable energy. We have placed primary emphasis on the map itself. And so if you look at the Marine Energy Atlas from the initial page load, what you see is a very large map with functional panels both to the left and to the right. We typically refer to those as drawers. So there's the left drawer and there's the right drawer. There's also a collection of mapping tools. And all of these components are very tightly integrated. You can maneuver data by manipulating the map itself directly via buttons in the legend items, as well as via the tools over in the left drawer. I'm not going to be able to show you every single feature, but I'll touch on every single feature at least once, but not from every place that you can access every single feature. So there's a lot of discovery that you can do on your own after the show today. So I would also like to make note that the application is still under active development. And so a lot of the stuff you're seeing today won't dramatically change, but there should be incremental improvements as time goes by. We do releases fairly regularly. Maybe, new features just kind of sneak in a quiet way. And so again, I'd just like to reemphasize, given that the application is currently under active development, it's a prime time if you have feedback, suggestions, usability issues. feature suggestions, all of those things we take into account, and we meet regularly. And so we'd love to hear from you. So on that note, I'll dive in. So yeah, the left drawer, the map panel, the right drawer. There is also, for anyone who's interested, there's a bottom drawer. And essentially, if you're interested in the privacy policy, the disclaimers, contact information, this is what exists in the bottom drawer. Each of the drawers, like the bottom drawer, is collapsible and expandable. And so if you're trying to maximize the screen space of the map, if you wanted to take a screen capture for a presentation you're doing of certain data, this is a great way of maximizing the map view. The data by default is a variation of the Wave Hindcast data that Katie and Aiden were discussing. You can see the 4 regions. The map has all the basic Slippy map controls. You can zoom into certain regions, you can pan, you can tilt the map, you can rotate the map. So if you're trying to get a specific view of an area, this is how you would do that. The map controls to the right, so not getting into the legend yet, but these are just the map controls. We feature several different base maps. So by default, we go into dark mode, everyone's favorite. It's also possible to switch into light mode, a satellite view. There are street maps, less relevant in Alaska. And in addition, we recently added nautical maps. This is part of an ongoing effort to include more and more relevant data in the atlas. And so in the near term, over the next few months, we're going to be adding a lot of extra data to the atlas. Some of which will be, new years of modeled data, some of which will be layers such as these nautical maps that simply provide context and additional surrounding information. All of the layers can have their opacity adjusted. So in this case, if I wanted to see more information from the nautical map, but also wanted to still view the omnidirectional wave power for this area, I could do so by adjusting the opacity. It's possible to turn off layers from right here in the legend. So if I want to remove the layer from the map, I can click the X button. Whenever the layers change, the entire extent of the map is automatically adjusted to show what data you have remaining. If I wish to view, if I want to add a new layer, I can come over to the data library and check the box. This adds a new layer. Again, the extent adjusts. If I want, I can go back to my target period. Again, opacity. Some of the layers feature a multi-display. And so this is one where we can show either points or a derived polygonal view of the data. And so the points are the raw data itself is point data. And when we show this view, it's a derived data set that is more visually informative. And so as you're watching the scale of the data itself, it's sometimes hard to interpret as points, but as polygons. And so you can toggle between both at will. So let's adjust a little bit. Let's adjust our perspective here. That's right. And so we'll head towards Frisco. So the process of, let's say we can move the Atlantic data, move the Hawaii data, leave ourselves on the West Coast. So the map itself features some interactivity. If we pick the right kind of data, so here you can kind of see, I'm flying by a little bit, but the data library features a filtering tool. So if you're looking for specific data, you can type in here and it will fuzzy match anything in either title or category. Some of our future soon to be implemented development plans include a lot of usability improvements for this data library component tool, especially given that we have so much more data incoming. It's become apparent that it needs to be a little bit more user-friendly, the way for navigating and finding the data. So, but here we are, we can look at some buoys. Some of these buoys, if you click on them, you can see a special pop-up. Clicking the link in the pop-up will actually open the page for the buoy itself, the data where it comes from. So that's just kind of cool. In addition, all of our layers feature querying tools. So I'm gonna really quick just switch up a little bit. So if I'm interested in querying, I can click this button. There's also a query panel over here. But clicking the query button brings me here. And since I clicked it in a specific layer, it selects that layer by default. if I wanted to, I could also open this dropdown and choose any of the layers that are in the atlas to query. But for now, I'm going to leave it set to the wave buoys. We have a variety of selection tools. So if I want to run my query by selecting a point and a radius, I can do that. If I want to select by drawing a bounding box, I can do that. If I want to select by simply clicking a point on the map, I can do that. Once I've chosen my area of interest, clicking the request query button runs the query. So in this case, I'm querying point data and the points are sparse, so there's only one at the location that I chose. If I were to open a query up for a denser data set, such as the omnidirectional wave power, and choose a bigger area, in this case, there's a lot more query data. So the results are paginated. You can see on the map that some of the results are highlighted. Those are the results that are on the current page. When I page through, you'll see additional results becoming highlighted, showing the ones that are currently on this page. Our application also features download tools. And so there are two types of download tools. There's one that is universally applicable to all the data layers where possible. If we have licensing constraints or something like that, we may not download certain data, but where possible, all the data is downloadable. And so you can access the download button here from the query panel on the bottom of the page. You also can access the download button over here in the legend. You can also go directly to the download panel. However, since I've been operating a query, I'm going to decide to download this query that I currently have in display. And so here it is. It's going to bring me to the query dialog. I want to briefly touch on the fact that we ask for an email address. So the reason is the workflow that we employ for providing download data to users is pretty compute intensive. It takes longer, in many cases, it takes longer to generate a download data set than a typical web session would last. I'm talking anywhere from a few seconds to a few hours in some cases. And so the way that our download tool works is you spawn a process, it goes into the background, it runs some asynchronous processes, either in Lambda or batch, that generate a download archive. That download archive is then sent to you via email as a link that you can click and download that archive. All those downloads, we have an expiration time of about 36 hours. So from the moment a job completes, you have about 36 hours to click the link and download the data before you would have to come back to the Atlas and rebuild it. So I want to clarify, when we take these email addresses, we don't store them for use as a mailing list, or we don't spam them. We are an official government entity where we're very, very, very concerned about user privacy and PII. And so I, encourage people not to be afraid to enter your email address if you do want to download some data. And you have to. So for start, I'm going to choose a data library layer. I'm going to type in my email address. I'm going to choose my omnidirectional wave power. So this selected data is large scale data. To download, select the large scale data option for the download type. So I briefly touched on the fact that there were different types of data that we can download. The wave data itself, the Hindcast data, is so high res that it's really impossible to download using one of our pipelines. So we have a custom pipeline specifically designed for downloading this type of data. The data spans multiple years. It spans multiple attributes, and there are literally millions of points worth of data. And so the source data itself is many terabytes in size. So therefore, it really isn't possible to just download the whole thing. In fact, it is actually possible. The data is on Amazon and it's free for public use. We can look at that in a minute. But so if you want all the terabytes of data, you can get them via AWS. But from our application, our tools allow you to select subsets of the data and download those through our tools. So instead of using omnidirectional wave power, I'm going to go back to the buoy data. I'm going to select a format. We choose shapefile, GeoJSON, CSV, or GeoPackage formats, and click the download button. You can see a little note at the top. It's telling me an email will be sent to marineenergyatlas@nrel.gov when the data is ready. So that's the download tool. I'm going to refer to my notes real quick to make sure I'm not missing anything. Yeah. Right, so a couple of details over here that I failed to touch on. The legend also allows you to change the stack order of layers. So in this case, if I wanted to move omnidirectional wave power above the points, I could do that by changing the opacity. You can see that the point layer is still there. I leave the opacity up, it disappears. If I choose to move it back again, now the point data is on the top. In addition, some of the layers feature, I kind of touched on this already, but the multiple, we call them dimensions, but you can show it as points or as this. There's also, since this data is temporal in nature, you can choose which time period, which time frame. In this case, there's monthly data plus an annual average. And so by choosing a different data dimension here, you'll notice that the map data itself is updated. These are essentially treated as discrete data sets as far as the map is concerned. Well, it's the same source data. All right, so that is the essential map and data navigation in the atlas. And I'd now like to move into talking more about the capacity factor. So Aiden shared with us some information about the capacity factor tool a minute ago. So let's dive in. So here's the capacity factor tool introduction page. I'm not going to read this, but here's a description of the tool and some extra information to help understand the science behind it. There are also examples of power matrix files that you could use as a basis to create your own power matrix files in the format that our tool requires. It's fairly brittle in that when you upload that CSV file, it has to be exactly what we're expecting or the tool won't work. I click get started. So there is a note right at the top and it's saying that logged in users analysis results are saved and can be revisited later. This is fairly important. The capacity factor tool does take a few minutes to run for a single region. And so if you're running multiple scenarios for multiple regions, as soon as you leave the tool, as soon as you leave the web page and come back again, all those results would be gone unless you've logged in. If you've logged in, your results are automatically saved to a database. When you revisit the app at a later date, log in again using the same credentials, the same user, and your results will be saved. So for now, I'm not going to log in. I'm going to run a capacity factor result. So you can select from one of our 4 regions. Then you find your capacity factor, your power matrix file. I might have some saved. So I've selected Hawaii. I've selected one of the sample power matrix files. I'm going to give it a name. This is any name. It's for you, for your use only. And click submit. So there's a status. It shows all of the jobs you currently have queued. It shows the current phase that particular job is in. Right now, it says it's calculating the capacity factor. Now it has changed to the next phase. It's creating the map data. Creating the map data is the final phase, and it's also the most time-consuming phase. And so that is going to run for a minute. While that's running, I'm going to clean up the data library a little bit so that we can have a better view of the data when it finally comes around. So here we can see the status. Here we can see any results that we had saved. Currently, there aren't any results since I'm not logged in. None of my previous results is here. And so the way the capacity factor tool runs is the user's power matrix file is uploaded into AWS. That is then spawned out into a series of several hundred lambdas. Each lambda processes a small part of the job. When all of those lambdas have completed, the results are stitched into tabular data. Then the creating map data phase that we're in now is spawned. That phase likewise spawns a series of lambdas. Each of those lambdas puts together the final results, which includes a database table that can be queried, used for querying and downloads. In addition, we create the map data. We use vector tiles, and so a vector tile is being generated on the background currently. When the results come in for the power matrix, they are treated exactly like all of the rest of the layers that we already looked at in the data library. And so the querying tools for capacity factor results are identical to the querying tools for layers. The search tools are identical to the search tools. The map tools, the ability to switch between points, polygons, adjust the opacity, et cetera, all function exactly the same as they do for the rest of the data library. So I switch my base map to something that gives us a better review of this data. So right now we can see a dynamically generated capacity factor result for Hawaii. Similar to the data we looked at before, you can view it both as points and as polygons. Similar to what we looked at before, you can choose the temporal dimension, the time averaging period that you wish to choose, and you can adjust the opacity, etc. What you may have noticed is that there's a graph over here, and this chart is auto-updating itself as I manipulate the legend panel over here. And so currently, the only components of this that are synced up are the time averaging period. So if I choose one in the chart, it updates the map. If I choose one in the legend, it updates the map in the chart. The chart here is showing the area in square miles for each bin of capacity factor present in these results. And so here you can see the legend also shows it. Our capacity factor results range from less than 2% to greater than 20%. For February, around this scope, we're seeing a lot of blue, but you can see, very clearly the difference between the lee side because the capacity factor is much better on the other side of the island. If I wanted to, I could filter these results. So I'm going to change my water depth parameter to a depth of 100. Yeah, that gets you sometimes. So 111 meters. The form fields automatically spawn a refresh after you stop typing for a moment or two. So we can set a very narrow range of water depth, and you can see our results are much smaller. And again, you can go back to default. So these currently don't also manipulate the map. This is another feature development that is coming very soon. And so we'll be linking the filtering capacity with the map layer so that as the graph updates with the new results, the map also would update so that you would only see results on the map that fit within your selection criteria in this detail panel. Similar, I'm touching on this quickly, but the data library, you can see our result here in the data library. You can see the metadata for that result via the dropdown. You can turn it off. You can turn it back on again. If I clear this from the filters in the data library, you can see your capacity factor results have a little lightning bolt beside them to indicate that that's a special result. I want to really quickly show you. So we have a result, but I haven't logged in yet. So I'm just going to refresh the application. And this shows what I talked about a minute ago. I'm back on my results page, but my result has been lost. There was no session token to connect those results with this user. And so there are no results saved. I've lost the work that I did. However, if I log in, and so our login options, you can log in with an Amazon account, a Google account. In the very near future, you'll be able to log in with a Microsoft account as well. In addition, if you wish, you could create an account in the Marine Energy Atlas using this dialog. So I'm going to sign in as a user we created previously. And now, as soon as I sign in, you'll see what is loaded are capacity factor results that I ran yesterday, and these were saved automatically for me. I can view the details. You can see it has shown up on the map as soon as I open the details panel. Just like everything else, it's the same, all the same functionality. Another difference is it has also saved any power matrix files that I uploaded previously. So these are the two sample power matrix files. Now that I'm logged in, they show up. So if I'm running subsequent jobs, I don't need to re-upload the same power matrix files over and over and over again. I can simply choose one, name my job, and submit it. As soon as this job completes, it's saved to the database and will be available indefinitely. There is an expiration on these, but it's a matter of years. So nothing to worry about. So let me see, check my notes real quick. Yeah, I think that essentially covers the main points. I did want to mention again, a kind of a confirmation with regards to logging in and logging out. We are aware that that there's a data sensitivity when you're talking about your capacity factor results and potentially your power matrix files that you're uploading. And so I want to make it very clear that as soon as you log out, I'm going to interrupt this job and just log out now. So when I log out, the whole interface refreshes, any tokens are cleared. And if you now go back to the capacity factor tool, you can see, first of all, we don't even have a drop-down menu for selecting capacity factor. We don't have any, we're not logged in, they don't exist. We go to the results panel, there are no results. So the tool is safe to use even on a public browser. As soon as you click the log out button, all of your session is cleared and your data is safe behind multiple levels. I mean, honestly, we're DOE, so our level of security far exceeds industry standard levels in terms of user information and private data. So I believe that's all I have to present now. I'm very eager to hear any questions or discussion or other conversations. So Katie, I guess I'll hand it back over to you.
All right, I will share my screen again, and that way we can pull up the discussion prompts. Paul, yeah.
Yep.
All right. Okay, so we don't have any questions in the Q&A that I saw yet, but does anyone have any suggestions of data sets or layers they'd like to see, or analysis tools they'd like to see added into the atlas? I'm not sure if people are able to unmute.
They are not, but if they want to, they can raise their hands and we can unmute them.
So we got a question from Deborah Rose. Can we download the average data to use for making your own maps? Yeah, so that data is available for download. Paul, what was the time averaging on the data? If we want time series data, you have to go to the large scale data download.
That's right. So I briefly mentioned it, but we didn't look at it. But there is a way there. So both. The answer is yes to both. If you're interested in downloading the raw model data, so the omnidirectional wave power or one of those, it's time series data, and you can download the raw data at full resolution using the download tools. When we're talking about capacity factor results, those are also downloadable. You essentially choose a time resolution, so you can choose the annual average, or you can choose any of the monthly data and download that one at a time. So yes, all of the data includes the spatial. If it's CSV, it will have the points, the lat and the lon as columns. Any of the other formats are spatial formats, which you could load into any mapping tool of your choice.
Thanks. All right. So Kelly asked, is there a similar workflow for power curves with the current data? Aiden, can you jump on that question?
Yes, yeah, definitely. Currently, we don't have a workflow for power curves directly, but that's definitely something that we could do with the current pipeline that we have. So we'll absolutely put that in as a feature request, and hopefully we can get to that next year or this next fiscal year.
Awesome. Sam asked, do you query the Hindcast data in real time, or is the product analyzed by month prior and then displayed? So yeah, Aiden, go ahead.
I suspect you're asking for the capacity factor tool, and especially when we're looking at the broad data sets and applying that calculation across everything, we definitely aren't calculating the underground or background joint probability distributions on the fly. Those are all pre-calculated based on the full data sets that we do have. So those do change dynamically as more data over longer periods come in. So as we're transitioning from 32 years of data to 42 years, all of those background data sets are recalculated and made available to the processing tools. But yes, I mean, even with those pre-calculated, these calculations do still take a little bit of time, especially to make the maps. But if we were to do it on the raw data sets, that would take even longer. So we're trying to streamline that a little bit for you. Hopefully that answered your question.
Yeah, so I'll just reiterate, that in order to have the results for the capacity factor tool pop up in a few minutes, all of those joint probability distributions have to be pre-calculated. And the Hindcast data specifically has been generated by PNNL and Sandia and was QA/QC'd. And so the time series data is up until 2021. So that's all prior data. So, any other questions or suggestions? What sort of layers would people like to see added into the app? Are there specific oceanographic layers, any environmental layers, geopolitical layers? We're planning on getting bathymetry into the app. That's one of the layers from the OES GIS dataset. But we're open to other suggestions. Has anyone in the audience used the capacity factor tool? Pop in the chat if you have or haven't. Oh, Kelly commented, if users want to do the data analysis themselves, you've mentioned they can download the data, but is the scripting also available? So accessing the Hindcast data can be done directly from the Atlas, but there's also the MHKit download package that allows users to access the data, as well as some analytical tools and scripts associated with this data.
Yeah, and expanding on that a little bit, Katie, there's definitely essentially any of the calculations that we are going to be doing in the Atlas will be based and available for any user through the MHKit analysis package and tools. So yeah, those are again freely available and can be used by anybody. But we are trying to have a little bit of a cross-platform usage capability with a lot of the tools that we're building as well. So when we are asking for, say, a power matrix to be able to calculate these capacity factor values, we are basing those calculations actually on what the water power side of SAM uses as well. So the power matrices that can be used in SAM are basically the direct format that we require in this app as well. So yeah, we're hoping to build a lot of cross-platform use cases based on just everything that NREL has previously built, and of course expand on it. So hopefully that answers your question.
Just to add, I assume that everyone is aware of MHKit. If not, in perhaps posting this in the chat as well, just for anyone who may not be familiar, might be useful.
Yes, that is definitely something I can do.
Thanks, Aiden and Haiku. All right, so Deborah, you elaborated. We can definitely work with you to get that data to you. Maybe one of the options would be spatially querying the data for the particular area that you're interested in. But you can feel free to email me or contact us at this email address on the slide, and we can work together on a call and get that data for you. So, and just for reference for everyone, if anyone is running into an issue accessing the data or they need something specific, feel free to contact any of us.
Well, I think that's it's great feedback. It's always good to hear from users who have used the Atlas before and had found things that they wanted to do but couldn't do. I mean, that's perfect. That's exactly what we're looking for. So I'll put the question: has anyone else used the Atlas? And if so, what was your experience like? What did you find certain pieces particularly useful, or in other cases, find portions where you found it lacking?
Steve asked, has there been any discussions to include wind velocity data as part of the ME Atlas to support offshore wind planning? So there's already a GIS platform for wind, but I think we're open to that as a possibility. Right now, the Atlas is focused just on marine energy.
Katie, I can add on to that. So,
Okay. Hi,
yeah,
Kira.
as you mentioned, typically how we've developed different applications within the software suite is each application does have its kind of focus technology. That being said, different data sets, including wind velocity, it is all highly accessible and is integrated in many of our other applications. So if there was a need for including across different technologies, we certainly could do that. Again, it's more for just organizational and clarity purposes of what the specific use is for the application, that we don't do this. But yeah, I would highly encourage, if anyone does want to access wind velocity data, please reach out. If you're unsure if the latest data set, I assume you probably have it. And yeah, this can certainly be done offline. But yeah, I guess that's my expanded answer to that question.
Yeah, and I could speak to that as well. I believe that was Steve that Steve that asked that. And I mean, there's a lot of potential in this space as soon as you really start to look at co-location and planning projects across different types of renewable energy sources. And especially with the platform that we're building everything up on right now, there's a lot of opportunity, especially with even just looking at down selecting locations where we could use wind or even solar data to sort of limit exactly, what areas would be suitable for those technologies, and then start to look at the wave resource or even the current resource as soon as we start expanding into those domains with new data sets as well. So there's a lot of potential, but of course there's identifying what type of things would be useful to end users is something that we would like to have a discussion on, so we could sort of tune everything to something that's less academic and more applicable to the ocean space. Hopefully that helps, Steve.
Yeah, and I just want to add to that we're hoping to add more tools and layers that will make the Atlas usable to a variety of stakeholders, not just wave energy developers. And as planning moves into different sort of multi-use planning projects for different constituents and stakeholders, I think that's an important thing to keep in mind. All right, Vince asked, for resource characterization for powering the blue economy, I would like to see solar and wind resource data as well. So speaking to that point, all renewables need to be considered for PBE apps. So yeah, as projects like the PBE project incorporate different sort of renewables and multi-use within the project. it'd be great to have these different layers and renewable project applications speaking to each other.
I know I mentioned it earlier on in the presentation, but yeah, these types of requests are huge. Paul already touched on this as well. That these applications need to be useful to the users, to this audience. So this type of feedback is great. So we can add that to the list of the coming new fiscal year of our list of improvements and additions. So Katie, did we want to move on to perhaps the user accounts? I think that as we expand our analytical capabilities, this is certainly an area of interest of just, what can we actually enable for repeat utilization? However, don't let me skip ahead if you want to touch on it.
That's fine. I was going to suggest that we talk about that. So the user account feature is a new aspect of the Atlas, and it was in the version that was just deployed by Paul yesterday. So we're looking forward to having people use that and let us know what they like or don't like about it, and what we can do to make it easier. What sort of layers and information would people like to have saved on their user interface when they return to use the Atlas, to make it as easy as possible. So if anyone has any suggestions or anything that's come to mind right now, or hesitations about using the user accounts on the Atlas, well, let us know. And Paul or Aiden, if you'd like to chime in with any sort of planned attributes that we're going to add to the user accounts, that'd be great too.
Yeah, Katie.
Go ahead, Paul.
Sorry, real quick, I was going to say the one big thing that we are looking forward to implementing again, like over the next 6 months or so, has to do with managing previously saved analysis results. And so managing meaning the ability to delete them, the ability to view them sort of in a more tabular view. So separate from the detailed view, we'll also have sort of like a user profile page that shows all of your Power Matrix files separate from the input form, where you can change the name, delete them, upload new ones. Same with your capacity factor results, the ability to manage those. So I think that's the scope that we've already identified.
Yeah, and as we add more analytical tools to the Atlas, it'll be a nice hub for people to highlight which layers are important to them for different analytical tools, see the results, have those organized according to what projects or analyses are focused on.
Yeah, Katie, I was going to say you might want to start showing off the multi-decision analysis tool that we have planned for next year so far, to talk about that a little bit.
Yeah, so we're hoping to add a multi-criteria decision analysis tool, which will incorporate results from the capacity factor tool or other layers within the Atlas, so people can help identify sites that would be amenable to marine renewable energy projects. And some of those layers would include environmental layers, geopolitical layers, bathymetry features, and then of course wave data. And part of the multi-criteria decision analysis would let users filter ranges of those attributes that are important, as well as weight them. So if there are certain features or criteria that are more or less important to users, those would be given higher priority in the analysis, and the sites and output would be ranked according to those features. So yeah, as we ingest more layers, that's something that would be fleshed out quite a bit, and suggestions for layers that people would like to see and are important for doing that sort of analysis is something we're looking to hear from you about as we work on that tool. So Vince commented there's a lot of useful spatial information on other mapping apps from BOEM, NOAA, and if there are any discussions with these agencies to bring this all together within one tool. So that's definitely something that we're working on right now. The bathymetry, or the nautical charts layer, was our first pass at doing that, ingesting some of the data from NOAA, which is publicly available. And we're working on collaborating with them on incorporating more layers and getting that data refined and easy to access and visualized at all spatial resolution. So I don't know if anyone has played around on the app yet, but the nautical chart data is still a little wonky right now, but we're working on refining that. It's better at closer resolutions. So as you zoom in, it's easier to visualize. But yeah, we're hoping to get as much information in the app as possible and work with these other agencies. But those conversations have just started. So as we hear from people who are using the app and let us know what layers they'd like to see on the app, it'll help sort of justify these conversations that we have with other agencies.
Yeah, and expanding on that a little bit to Vince, one of the, I mean, the nautical charts is definitely our first foray into bringing outside data into the atlas, but we are definitely looking at, I mean, even if you just consider the wind and the solar data as another first step to that, being able to expand that, one of the things we are trying to do is also put that data in a format that'll be consistent across everything. So it'll solve a lot of problems of having to write new analysis methods or scripts or something like that to look at something very specifically. So yeah, as part of bringing in new data into the atlas and making it available, we are trying to compile everything into something nice, neat, and something that'll be relatively straightforward and easy to use. It might be a big stretch to say easy to use, but definitely something that's gone through a little bit of QA QC and can be integrated into a lot of the data sets that we already have available. But yeah, that'll be a big improvement as soon as more data starts to come in.
All right. We have 2 minutes left. If anyone has any last burning questions or comments, we'd love to hear it. And as I mentioned, if any questions or suggestions or ideas come up after this webinar, please feel free to contact us. We will send out the PDF of these slides immediately after the webinar. So you'll have this Marine Energy Atlas at NREL.gov email, as well as our emails to contact us. And we'd love to hear from you all. More feedback is better.
Awesome. Well,
Thank you.
All right.
Thank you. Yeah.
Thanks everyone.
Thanks, everyone. Goodbye.
Enjoy the rest of the day.